All right, let's actually use the first derivative test. So we already found the critical points for this function in an earlier video, right? We said the critical points were at 1, 6, and 3, 2, I think. Is that what we said? Yep, we did. And now we want to use a first derivative test on these points. So we're going to create a number line, okay? And we want to plot our critical points. Here's 1, and here's 3. All right, wait. So what we're going to do is find out, what does f prime look like in each interval. So we want to find out, is the function increasing or decreasing in this interval? Is the function increasing or decreasing in this interval? And is the function increasing or decreasing in this interval? And we'll have a very similar picture to the example in the last video. So let's pick a point between 1 and 3. Any point here. I don't know. 2 seems like the natural choice, but you could do anything. If we look at 2 again, these are our critical points. These are the things that we really care about. What is the sign of the derivative here? Well, what was the derivative? We said the derivative was 3x squared minus 12x plus 9. And we ended up factoring that. And when we factored it, we got x minus 1 and x minus 3 like this. So we don't care about the value of the derivative right here. We just care about the sign. So you can plug it in and you can get a value if you want. But what I really like doing is a shortcut. If we plug in 2, what does each term look like? 3 is positive if we plug in 2. If we plug in 2, this is positive 2. This is positive as well. This is positive 1. And if we plug in 2, this becomes negative. That tells us that the derivative is negative at this point. Again, you could actually plug in 2 and get the value itself. Or you could just look at the factors and say, okay, positive times a negative is a negative number. We just care about the sign anyway. That tells us the function is decreasing on this interval. And now we want to figure out something for this interval. Any number in this interval. Let's pick 5. Or you could pick 10. It doesn't matter. All right. But let's look at what the slope looks like for the function at some number in this interval. Well, 3 is always positive. If you plug in 5, this is positive. And if you plug in 5, this factor is positive too. So if we plug in 5, we just get a whole bunch of positive numbers multiplied by each other. That gets us a positive number. That tells us that the function's increasing here. Oh, so 3 is a local minimum. And now we need to plug in something in this interval. You could plug in 0. You could plug in negative 1. I love plugging in 0. 0 is one of my favorite numbers. So we could go off to the side and do that as well. 3, still positive. Plug in 0. This becomes negative. Plug in 0. This becomes negative. Positive times 2 negatives is a positive. That tells us the function is increasing here. And that tells us what our critical points look like. Now, I feel a little silly right now because the astute observer will notice that this is actually exactly the same. I chose one number that was different, just so it would be different, but this is basically just example 6. Okay. But this is how we actually go about using the first derivative test. Okay. And then I want to also show about wording, because the wording on these is kind of tricky sometimes. All right. So what we're going to say is that f has a local minimum of 2 when x equals 3. So the local minimum is the y value. Right? This point 3 comma 2 is where the local minimum happens. And this is the phrasing that we say. F has a local minimum of 2 when x equals 3. And similarly, f has a local maximum of 6 when x equals 1. So that's the wording. The wording is always the minimum and the maxima are y values. Okay. The minimum is not this. This is just an input value. We want to know the smallest this function gets in a region. And the smallest the function gets in that region is 2. The biggest that function gets in that region is 6. That's kind of a small thing. We'll talk more about it later. But it is an important thing. Okay? Well, the next video talks about something called the second derivative test. Maybe you want to use a second derivative to classify whether a critical point is a maximum or minimum. And we've got good news and bad news about the second derivative test. So the good news, well, I don't want to spoil it. You're just going to have to come back and find out. Bye-bye.